Welcome to CAD with Mr. Yu, your CAD resource. In today's video, we're looking at part 5 of 6 videos covering the topic how to draw an involute to a circle. We thank you for joining us and we'll be starting the video now. Height to the 4 rotational angles. This point would be O. Alright? So what we're going to do, we're going to bisect OP. Now recall that the circumference was 125.6 millimeters. So this line is about 110 millimeters because it would be shorter. All right. So 110 half of 110 would be about 55 millimeters. So what we're gonna do, we're gonna go arc, center start, and we're gonna use any radius as long as it is greater than half. So we're going to use 60 millimeters, enter, and we're going to mark the arc coming around like that. All right. Same radius from P, which is 60 millimeters. So we're going to select there. This radius will be 60, enter. Where the two arcs intersect, that will be the bisector. All right, so we're going to draw a line through the intersection of this arc here. So we go intersection, intersection, end. All right, so that is a bisector. So we're going to label this point M so you can follow along, right? In the exam, you wouldn't worry to label it M. So I'm going to label this point M. The M is where the bisector intersect the line OP. So what I'm going to do now, I'm going to draw a semicircle to intersect the circle, right? But what you do, you draw the semicircle on the open end of the involute, all right? So we're going to go arc, center start, and the center will be at the center. We need to turn on objects now. So we come here, and this will be the radius from P. And we're going to come across just like that. Enter. All right. Where the semicircle. What we can do so that you can follow along easily, right? What I'm going to do, I'm going to put these. All right. So what we're going to do, we're going to zoom up. All right. So where this what I'm gonna move the 40 millimeters. Good. I'm gonna put it right there. All right, where this semicircle intersect the circle, recall from our previous video the construction of a tangent from a point P to the circle. Where intersect, this will be the point of tangency. So what I can do, I can label this point so that you can follow along. N. So right here, you're gonna turn off object snap. Right here would be N. The height will be 4, rotational angle 0. This would be N. So recall, N is right here. So what I'm going to do, I'm going to draw a straight line from N to P, and that would be the tangent from the point P to the circle. All right, so let's go now. Line at N. N is right here. We need to turn on objects now. N is here. We're going to join it to P. I'm going to turn our object snap is on. is right here. Good. Enter. So this line, which was a tangent from a point to the circle, is now the normal for the involute. All right. So I'm going to extend the normal. It's now the normal. In the previous construction, it was a tangent from a point to the circle. But the application of the tangent from a point to the circle on the involute gives you a normal. All right, so I'm going to extend the normal so I can label it for you. Enter. So we're going to type extend, shortcut EX. I'm going to click on this line. Good, there it is, enter. I'm going to delete this line, all right? It's not needed, it's not part of the construction. So what I'm going to do, I'm going to label this line normal. So I'm going to go single line text. Gonna turn off object snap. And the start point I'm going to choose here. The height will be 4. The rotational angle looks like about 45 degrees. Enter. So I'm going to write normal. When I click outside, right, it's 45 degrees. All right, good. Now, can you recall we did the Archimedes spiral? Can you recall what's the next step to get the tangent? So the Archimedes spiral, we drew a normal and tangent to the Archimedes spiral, which is the previous video that we did some time ago. So the next step is to construct is the same principle that we use in the Archimedes spiral, right? So having gotten the normal, we're going to construct a perpendicular at the point P on the normal, right? So we're going to go arc, center start, and the center would be at P. We need to turn on object snap. So we go P, intersection. The radius would be, let's use 20 millimeters. No, let us use 15. Enter. And we're going to mark the arc coming around like that. Good. I'm going to label the points here. So we're going to label this point. We're going to turn off object snap. We're going to label this point. Uh, let's call it T. But it's really a number I want there. All right. So let's call this. All right. So we need to go single line text. The start to be here. The height to be 4, rotational angle would be 0, enter. So let's call this point what, R, and let's call this point S. So at R and S, we're going to mark 2 arcs equal to radius 15, which is the radius that we used previously. We need to turn on object snap. So come here. This radius needs to be 15. Enter. Good. We're going to repeat the process at S. It's really a number one. We have S, but I'm gonna zoom up so I can see the intersections. That is there. The radius, I'm gonna zoom back down. The radius would be 15. All right, so the radius would be 15. Enter. Good. We have come to the end of today's video. In today's video, we drew the normal and tangent to the involute of a circle drawing, and in the part 6 of the 6 videos, which is the next video, we'll be continuing the drawing. So we're looking forward to seeing you in that drawing. Please take care until then. Bye. Thanks for watching the video, and don't forget to subscribe, hit the notification bell, like, comment, and share.